Hi there, everyone. Welcome back. Great to have you back with us. Hey, Jonas, how you doing?
Hi there,
Good
I'm
stuff.
good. What about you?
Excellent, excellent. Yes, doing well, thank you. The looking and sounding good. Thank you, Kent, for our official slash unofficial technical achievement person. Excellent. So we're just making sure it all works, which it does. This is great. So officially, I'm Simon Walker. I'm Director of Training at Maxon. And we're delighted again to have Jonas Pilz back, one of our expert trainers. Hi, Jonas, again.
Hi there again.
So the idea now, if you've come to some of the other sessions, you'll know the format. Jonas is going to run through a whole bunch of fantastic techniques. And today we're looking at the scene reconstruction in this third session of these three. And if you missed the other two, this PDF will be available in a link that will email you directly. And you'll get an email because you registered for this webinar, you get it automatically. I'm sure you know the scene now if you've attended before. And if you wanted to watch any of the earlier ones, then you can just click on the dates for those. And then that will take you through to the recording. So, hi, Logan. Logan's saying hi, good morning / afternoon. It's afternoon for me and morning for those who are joining us from the States. And we usually get people from a whole range of places. Also, we have Darren looking after the questions. Again, thanks, Darren. So please feel free to ask away, and we'll either interrupt Jonas or we'll have to give you a direct answer on the questions too. And also, if you don't have your question answered, if we don't get around to it, or you think about answering one, or you're watching the recording, you want to ask one, please contact us training@maxon.net and let us know any requests as well for future webinars like this. Fantastic, great. And just to reiterate, in case you just joined, we are recording this and we'll send you the recording automatically. In fact, I'll put the link into the chat window as well, but you'll get it. Great. Okay, so I'm going to hand over to you, Jonas. I'm very excited for this one. This is going to be a fantastic session. I was going to say that you've held the best for last, but that would be quite something to top the other two sessions that you've done.
Let's see. All
right, so
right.
you should have the screen now. And
yes, here we go. You should see.
I can see it.
Go.
Great. And if anyone can't see Jonas's screen, then please let us know in the chat. There should be an automatic window that pops open and you can see it.
Yeah. All right. So yeah, let's start. Welcome to the last day of this webinar series. And today we are going to talk about scene reconstruction inside of Cinema 4D, which is quite an interesting topic. And yeah, it pretty much sums up everything that happened before and adds a nice little goodie on top. So what is scene reconstruction? Basically, you can reconstruct a 3D scene out of filmed footage. What can this be used for? And let me just go through some use cases here. So here you see this little fireplace, which is, by the way, the scene for that is in the content browser of Cinema 4D. And what you see here is that it can be used for creating reflection and shadow geometry, or for casting and receiving shadows and reflections. For example, here on this sphere, you can see that this part of the wall is reflected here. And this whole thing has been reconstructed automatically and can now be used for reflections. I will open this scene up in a minute. Then there is the next one. It's a pretty similar thing where I also had a chrome sphere on the video plate here. What I did here was I reconstructed all of that stuff. You can see still this thing here is here reflected, and then I put a mill on top because this was actually the ground plane or the base of a mill on a field. And I used the reconstructed geometry in order to recreate parts of the mesh here, and just use that for the reflections. The next one is a shot that I worked on like for a week or so, and it shows remodeling a scene based on the result that comes from scene reconstruction. So you might have seen it before. So it's this little statue that's opening up its eyes when the bubblegum bursts. And here's a little breakdown. So this is the original video, the motion tracking pass, the scene reconstruction pass, modeling and animation. And here you can see actually how I remodeled it. So I got a good edge flow, for example, and was able to add all of the weighting and the animation and so on. I will also open up the scene reconstruction part of this one. And then, of course, then there is this one that you might have seen on Twitter. It's the tree crystal growth effect. And of course, scene reconstruction can also be used for creating surface effects. One thing I forgot to mention, when you recreate geometry, you can also use this as collision geometry for dynamic objects, for example. I even had a really good example for that, but unfortunately I noticed that we don't any longer have got the rights to use the original footage, so I have to create another one. So let's maybe start with the good to knows, but this time there are just two of them. First of all, there needs to be a camera solve coming from the motion tracker in order to reconstruct a scene. So you have to go through all of the tracking steps in order to get a scene reconstruction. And the second one that is good to know is, as with the motion tracking, not everything can be reconstructed, and surfaces with a lot of detail work best. And this is why you will see me showing this on footage that has got a lot of surface detail, like here the sandbox, for example, and I reconstructed this actually for the R20 presentation, and here you can see the reconstructed mesh of it, and it worked really well because you got all of these little details and a lot of spots where the tracker can follow, and also scene reconstruction will benefit from that. All right. Before we reconstruct the scene, let me just jump into this one, because this will show the fireplace scene. And as I told you before, this is part of the content browser. So everyone that has got the content libraries installed, and the content libraries come for free with Cinema 4D, will have this scene. Now let me jump out of the camera. And let's see, this is the 3D geometry of this scene. And this is quite impressive. Let me get rid of the texture here. So you see the real geometry. So this is the geometry. And it's not just geometry. Like here you can see that it's really dense. It is also geometry that includes the color information. So here is a vertex color tag. So scene reconstruction creates this vertex color tag automatically, and it stores the colors that it finds in the footage directly on the points of the geometry. And later, if you need it to be more accurate, and that's what I did here, you can also use camera projection, for example, to reproject the original texture onto this geometry. Right, so let's jump into the next one, which is the face that I actually captured or shot in Prague. So here you can see the video played, and it's not just the video played, because this is already the reconstructed thing. When I enable the mesh, this is the mesh here. And if I jump out of the camera, you can see that it looks like that. And this was completely automated. Again, you can see there's a lot of structure here in the surface and so on, and this helps a lot. If we just jump out of the vertex color tag here, you can see that this is really noisy. So usually what I do, and I will also show that later, is, let me show this one. I add a fong tag just to smoothen the shading, and then I also add a smoothing deformer just to smooth it a little bit more, just to get rid of the noise. It's not at 100%, it's just a little lower, so it gets rid of the noise, but not of the detail in the shape. And then in the end, I will just current state to object the whole thing. So I've got one object that doesn't need to be calculated anymore, because the smoothing well, has to be calculated at some point. And then the last one, it is this one here. Also, that's something I shot in Stockholm. And this one is quite interesting because it was really, I just created this whole scene within 30 minutes. And let me just get rid of the depth of field. So we've got a, oh, sorry. So we've got a good frame rate here. And let me also get rid of the textures so you see what came out. So this is the model without a texture. And this is with the vertex colors applied. And if I bring that back here, oh, maybe I should just undo this until we are here. This is also just the texture, reprojected onto the thing. And if you noticed, or if you watched the Apple platform State of the Union presentation, this was even part of that. Okay, so now let me jump into my other instance of Cinema 4D that is running right now. It's this one, and maybe let's also get rid of the dock here so we got more space. Here we go. Okay, what I already prepared is the original plate of the tree crystal growth shot that I created. And you can see there's a wall in the background, and there is some soil in the foreground, and the tree, and a lot of detail here, and not as much detail back there. And we will go through the whole process, so I will track all of this again. So let's select the motion tracker, and we already set everything up here in the footage. So I go to 2D tracking and just hit auto track. For those of you who couldn't attend the first two webinars, this is the path where it tries to find features in the video that it can follow along, and then it sets a tracker and follows them along. And it does that multiple times in the scene until there is until there are many trackers. And once this is finished, and you can see, although this is a shot that is 360 frames long, it's almost finished. It's processing forward and backward. And here we go. So now the 2D tracking pass is already finished. You can see now that there is a lot of trackers, and they follow the footage here. So what I would usually do is I would filter tracks out, bad tracks, of course. And I usually do that by just enabling error threshold in addition to the two that are enabled by default. And I bring the error threshold down to, let's say, 20%. This will get rid of a few of the trackers. And then I directly jump into 3D Solve, just make sure that we are at solve mode, full 3D reconstruction, and the focal length is unknown but constant, because I didn't know the focal length for sure here. And then I just hit Run 3D Solver. But I will skip that step because I already did that in the past. So let me open up the Finder, and let's just open up the next scene here where the solve is already finished. So we save like 2 or 3 minutes of time. So here we go. That's what comes out of the 3D solve. So now we have got some nulls here that represent the scene. And we are also out of 2D navigation mode. So now let's select the motion tracker, and let's lock the solve data. And now let's align the shot. Because right now it's aligned somehow in 3D space, and we need to align it in a way that, for example, this here is the ground plane and so on. And we do that by adding constraints. So we add a position constraint to define the origin of the scene, and I will use this null to define the origin of the scene. And you can now see that the origin just was moved to this place. Then I go to create planar constraint, and I use, let's say, this one, and this one. It asks for 3 inputs to define the ground plane, and now it's already looking quite good. But in order to scale the whole thing, we need to create a vector constraint, because with a vector constraint, I just define a length, and now we can already tell this length to be, for example, x-axis, like so, and then we can also say that we know the length, and we will set it to, let's say, 40 centimeters, and then we are good. So here we go. The scene is now completely aligned, and let me have a look at this in 3D view. So let me rotate around here. So you
I have a
already
question
get...
for you, Jonas, when you have
Yes.
a moment. I don't want to interrupt
Yes.
your flow, but William's got a good question. But
Yes.
is that okay? Fan. He was just wondering if you would mind just mentioning or commenting on the memory setting in the motion tracker in the preferences. And he's found that if Cinema doesn't have enough memory assigned to the cache, then it can slow down the tracking. I just wondered if you had found that.
Yeah, that's indeed true. So if you run into that, and thanks for making me aware of that, because I didn't mention it earlier, you can go to Edit, Preferences. And in the Edit Preferences, there is one section that is called Memory. And in here, you can set up the maximum RAM for the picture view, for example, and for the motion tracker as well. So usually I don't run into these problems because I up them immediately when I got a new installation of Cinema 4D. But those are quite critical, because it is indeed the way that if you don't have enough footage cache here and the sequence is too long and well, it is bigger than the cache allows, then it will slow down the tracking, of course. And it's the very same thing for playback in the picture view, for example. So usually, I think the default is like 2 or 4 gigabytes, and I always up it to like the maximum that's possible in combination with all of the other settings. Same also is true for displacement. So displacement rendering will also be faster if you do that. And also sculpting. So sculpting also has got the memory here. So that's also important to know. Good point. Thanks for that.
Yes, thanks, William.
And yeah, let's just continue, because now we already have a good idea of what the scene looks like in 3D. And we can just elaborate on that and continue by going to reconstruction. So until now, I showed everything in the previous webinars on Tuesday and Wednesday. And now, so this would be the default view here of this window. This is the new tab. And well, it might be a little bit unfortunate for you, but I just have to tell you that from now on, it's just 4 or 5 clicks to come to the complete reconstruction. You just choose a preset: preview, medium quality, high quality, or custom. I usually go with high quality, but for this webinar, I go with medium quality because it will be faster. And here in the advanced settings, you can see that when I adjust these presets, it will just adjust these parameters here. And let me set this to medium quality, and then I will just click Generate Point Cloud. And because it takes a while, I will explain a little bit. So you can generate just a point cloud, or you can generate the mesh. If you generate the mesh, it will generate the point cloud in advance to create the mesh. So the point cloud needs to be there to generate the mesh. Then there is a parameter that is called iterations, which means that something happens multiple times. In this case, 2 times. So what happens? Right now, what's happening is an expansion pass. So we are expanding the positions that we already have here in the stored in the motion tracker. And then Cinema 4D or the tracker expands them and compares the colors, the color information there with other frames. And if there is a match, it will create a new point, more or less. That's the simple explanation. So it will expand the point to a little patch of colored points. And then there's some filtering going on, and then there is the next expansion pass with iteration 2 in this case, and we are in that right now. And then it will expand again. And yeah, with the high quality, it will even expand one time more, and you can bring this up to very many iterations, but actually this will just make everything take a lot longer. So right now we already finished this, and as you can see, this is the point cloud that comes out. Maybe let me get rid of the features here. So this is already looking really cool. If we zoom in, you see that it's just points in 3D space, but maybe you can use them already. And now we get an even better idea of the scene. But of course, because it's just points, we cannot use that as collision geometry. We cannot render this and so on. So we have to generate a mesh from this. As I said earlier, this point cloud needs to be there in order to generate the mesh. If it's not there, it will generate the mesh once you hit, it will generate the point cloud once you hit generate mesh, and then automatically continue by generating the mesh out of this. So sometimes you have got less points than here. And there can be multiple reasons for that. If there's enough structure, you should have a look at the camera move. And if it's a camera move like here, where I go from one side to the other, well, pretty obviously, then this setting or this should usually be okay. If you have got just a straight move and just a dolly or something, then it can be that there are less points, and then you would have to lower this minimum angle here in order to get more points. This will also introduce a little bit more noise, but you have to find the right balance and maybe do this multiple times until you get to the result that you want to have. Well, a nice tip here is that you don't do that you shouldn't do that with high quality all of the time, but do your testing with preview or with a medium quality preset. And then if you are happy, just go to high quality and do it again, unless you want to wait like for another shot or another attempt to be finished. Good. So now, well, that's basically it. Now we finished scene reconstruction here. So let me just get rid of the point cloud here, and let's put out the scene mesh here, and let's have a look. Okay, that's looking quite well. We've got a little bit of noise in here, but that's okay. We will get rid of that in a second. And yeah, so that is the scene reconstruction. If we now select the vertex color tag, you can also see that there is the color information in here. So it's a very simple process. It's just a few clicks, and depending on your quality setting, a lot of waiting or not. And then you get something out of this. But I mentioned it earlier, areas with high detail or with many details work best. You can see that the reconstruction was finished until here, or well, goes until here, but then it stops. And this is because there is no detail anymore. So that's the point with scene reconstruction. If you have a lot of detail in your surfaces, it will work really well. And if there is no detail, you cannot really get a scene reconstruction. You have to create all of that manually. Okay, so let me jump out of the camera here again, and we want to continue by creating the growth effect. I think it doesn't make sense to show you the same workflow now 3 or 4 times. So I will show you something else, which is cool. And let me jump back into the keynote and let me go back to this one. Now we will create this growth effect here. So this is a very nice one, and it's also one of my favorite things that can be created inside of Cinema 4D because I love growth effects. So let me have a look at the mesh, and let's just clean that up a little bit. And to do that, I will create a smoothing deformer and make it a child of the scene mesh. And you can see, wow, now it's a lot smoother. But the point with the smoothing deformer is that it also, well, it changes the surface, it changes the shape. So you shouldn't do that too much, just like 10 or 20%, that's enough. And then right click and create a modeling tag, which is going to be the font tag, and this will smooth the shading. So
got a couple of questions for you, which might fit into this section now, Jonas.
yeah,
A couple of people asking, actually quite interestingly, about photogrammetry. Reese is asking, could you also use a series of images and process through something like reality capture? And also Marcus is wondering, if you're doing that traditional photogrammetry routine with high megabit photographs, would that be another method to do this? And whilst you're thinking about that, another question is, if you're for the original video, is it better to have high frame rate?
Well, high frame rate is always good for motion tracking because you have got less motion blur. So that would help definitely. It will also take longer to track a shot then. But in terms of quality, I think yes, it makes sense to have a high frame rate. Photogrammetry, that's a good question because some of the results I got from scene reconstruction are so good that you could use them as some sort of 3D scan. But keep in mind that this tool is not a 3D scanner. It's also not a real photogrammetry tool. So we had that in our test phases when we developed this feature. We also imported just image sequences of stuff, but keep in mind that the motion tracker has to run before we started that pass. So to do real photogrammetry, it might be better to use, or it definitely is better to use a photogrammetry tool. But in theory, it's possible, yes.
Got it. Okay, so it's a different discipline,
yes.
Related, of course. Okay, thank you.
Yeah, exactly. Okay, so let's continue by just right-clicking the scene mesh here again and just go to current state to object, because this way I create a mesh that has the smoothing in it, but no smoothing deformer anymore. And we will call this tree. And here we can now start to clean this up, because what we actually need to create the growth effect, let me just jump back into the camera here. It's actually just a little section of this. We don't need the whole background, we don't need the full foreground and so on. So let's just get rid of, well, a lot of this. So I go to the top view, and in the top view, I go to points mode. And then let's see, here we can see some of the roots. And this is already very helpful information, because now we can go to the lasso selection, for example. And let's just draw a shape like, oh, that's too much. Maybe let's undo this. Let's just draw a shape like this. So here we go. Something like this. And now we've got the points selected that we actually need. So let me go to select and invert the selection and just get rid of all of these points. Now let's have a look again at perspective view. That's what we have now. And let me scrub through the timeline. As I look through the camera, there's still a lot of stuff that we can get rid of. For example, let me go to the light selection tool and make the radius a bit bigger. Simply by using middle mouse click, we can get rid of this, and we can get rid of that, and so on. And the reason I'm getting rid of all of that is because I want to create this growth effect. And the growth effect will use a vertex map as a base. Now, a vertex map is a weight map that is based on the point data here. So the less points I have, the more performant the map will be. So let me also just select one point here, then go to select connected, and then invert the selection, because this way I get all points that are not part of this big chunk here, and I can delete them as well. And now let's say I'm finished with that. I could also get rid of the holes here and close them, but I won't do that now because it would simply take too long. Right, so let me also jump out of the motion tracker layout and use the startup layout. And now let's create the growth effect. So we go to points mode again. We select our tree footage here, and I'm also gonna leave the camera here. And now I will use my live selection, make it a little bit smaller with middle mouse click again, and just select a few points here. And I want these few points to be the starting point for the growth effect. So I go to select, set vertex weight, and then this little window pops up, and I type in a value of 100% because I want to set a value of 100% weight for these points here, hit OK, and this created my vertex map. You can see that there is now a new tag here. This is the vertex map tag, and this vertex map tag stores a weight value, so a value between 0 and 100% on each vertex or each point of the geometry here. And if I zoom in, you can see that some are yellow, some are red. Yellow indicates 100% weight, red indicates 0% weight, and all of the shades of orange in between are or represent a value between 0 and 100%. Okay, now let me just deselect the tree, but select the vertex map, and let's hit play, and you see that nothing happens. And of course, we have to set up the growth effect first. So let me, again, select this vertex map tag. And then there is a little checkbox here. It is just a checkbox, but if you open it up, it will unleash the full potential of Cinema 4D's unified weighting system, which works all over Cinema 4D. And this is the fields system. So here we've got the fields inside. And fields are, well, the field list is a layer manager, pretty much like in Photoshop, but you can add, subtract, multiply, and whatnot, layers of weight with each other. And to showcase that, let's just create a linear field, and let's make it a little bit smaller. So here we've got the linear field, and move it from the left to the right. You can see that we are changing weights, and this is a really powerful thing because it doesn't just work here with vertex maps, it works all over Cinema 4D, like also with MoGraph, with volumes, with dynamics, and so on. All right, but the linear field is just for showcasing the principle behind it. Now, let's have a look here. There's already a freeze field in the list, and the freeze field just remembers the initial weight, the one that we set up. And in the freeze field, there is a mode parameter, and we can set that to grow. And that's actually everything we need to do. So let's hit play, and you see, wow, we've got a growth effect. Of course, it's way too fast, and this is mainly because the radius is too high. So let's bring this down to maybe 2. And then you see, okay, it's still quite fast. But I'm also happy with the radius here. So let me decrease the effect strength, because by using the effect strength parameter, you can counter the speed of the effect initiated by the radius. So let's bring this down to 25%. So we've got 25% of the initial speed, and now we're getting somewhere. Of course, well, at least for my taste, we can see too good that this is like a circular movement, that it starts somewhere in the middle and then just expands. And I want to break this up to be a little bit more organic. And the point here is that you can, what I already told you, that you can combine fields with each other. So I will search for another field that introduces some noise or randomness, and there is a random field. So let me create this one. And now it's on top of the freeze field. So you see the randomness. So these are also weights. Yellow represents 100%, red represents 0%. And then there's a good question, which is, would it be possible to drive the radius here with another field, like the random field here? And the answer is yes, because we can unfold the freeze layer here, and the radius parameter has got a subfolder or a folder. So we can just move everything that we want to control the radius into that folder, and then it will control the radius. So if I now hit play, you see that this is completely different. It's way more organic, but of course we could use another shape, and we could also, well, just like make the effect less strong. And to do that, I will just select the random field, and then I will go to the remapping here, and I will set the min value from 0 up to something like 25, 20, or 30%. Let's hit play again. And you see, yeah, that's cool. So it's a little bit softer, so to speak, but still very organic. And that's our growth effect, or the base for our growth effect. Of course, we can take this way further, but I will leave it for now, or maybe I will just bring it up to 30% and then leave it. So this is our growth effect. Let me jump back into the camera so we can see what that looks like in motion. And I'm really happy with that. And now let's find some ways to use that vertex map and to visualize it somehow. So we want to drive two effects with it. First of all, we want to address the shading with it. So we will create a material and assign the material to the tree. And because this has to be a fast setup, I will just use the color channel here. Otherwise, I would use reflectance. But in the color channel, I can show it the fastest. So let me add a texture here, or a shader in the texture. And let's go to effects. And down here, there is an entry called vertex map. So actually, in a shader, in the vertex map shader, we can read the information coming from this vertex map when we drag it in here. And then you see that everything is black except for that spot here. And if we hit play, you can also see that the spot is growing. So right now we're using the information we just created in the shader. So now the question is, how can we recolorize this maybe? That's also simple. Just click here on the texture parameters arrow down and go to colorizer. Now we create a colorizer, and the colorizer just maps values from black to white to whatever you input here in the gradient. Maybe let's unfold the gradient, and for the black value, I want to pick a color. Let me go with this one. So this is a gray, and then let's use something greenish for this part. So now we colorized it, and we can also bring the knots closer together, and this will create a sharper edge here. So now it looks like this, which is also really cool. And the next thing I want to add, and I will just go one up and copy the whole effect, and then I will activate luminance and paste it here, because what I want to do is I want to create an outline here. And the easiest way to do that is also by using a colorizer with the vertex map inside. But this time, let me reset the gradient to default. We will use a gradient that maps black to black. Then it maps 50% gray to white. And then I will copy this over by holding Command. We will map white to black. And this will result in this nice little outline. So if we just make this a little bit smaller, you can see that we now have a growth effect with an outline that is, that is in the luminance channel. All right, so this is already pretty cool. But now let's create the crystals on top of that. And the crystals should only grow here in the green area. So let me first add a new scene, or create a new scene, and add a cylinder. And the cylinder should be oriented towards Z, because the Z is then later the direction that goes away from the surface. Like the Z direction is, like orthogonal to the normal, to the surface normal in MoGraph context. And then I will bring down the radius, and I will bring down the height segments and bring down the rotation segments to 6. And now it already looks a little bit like a crystal. And then I will make this editable and go to the mesh menu, or first go to points mode, then go to the mesh menu and choose the line cut tool. Deselect visible only and just cut right through it, but diagonally, like so. And then I will just use the rectangle selection to get rid of these points here, delete them. So now I have got this, and I can just right click the mesh and choose close polygon hole. And this is a tool, so we have to click once, and now we close the polygon hole. And this is one crystal. Let me just move some of the points over, because this is going to be the pivot later. So let's move it to this place, and let's also make it just a little bit longer and rename this to be crystal. Good. Perfect. Let's copy this. So I hit Control Z, and then I go to the other scene, to this one, and I paste it. And as you can already see, it is way too big. So we scale it down like so. And then we create a cloner and make the crystal a child of the cloner. And here is the interesting part. So let's select the cloner. Let's adjust the mode to be object. And when it's set to object mode, it needs an object as an input. So I choose the tree. And now it already clones these objects onto the tree. Now we want multiple of these, like 10,000 or so. And in order to keep the viewport responsive, we need to adjust the instance mode to be multi-instance. That's quite important. And then we can just bring this up to 10,000, for example. And here we go. That's 10,000 clones. And I can already see that these are a little bit too big. So let's make them a little bit smaller. And let's also maybe go with 12,000. Right. So now we have clones all over the place. How do we restrict them to the green area, or to the area where we have some vertex weight? And the answer is with an effector. So with a MoGraph cloner selected, because this just creates the clones, we need effectors to affect them. We go to the MoGraph menu here and just use a plane effector. In the parameters tab, we just disable position because we don't want to affect it. We want to affect two things. First of all, we want to affect the visibility. Affecting the visibility makes sense because if you have got many clones in the scene and you really make some invisible, they won't be calculated. They won't be part of the calculation, and therefore the viewport will be a little bit faster and all of the calculation will be a little bit faster. And then I will use a second one to scale them up. So first of all, let's set this up. Now we set it to visibility on, but of course, nothing happened because we need to restrict that visibility setting somehow. And to do that, we go to the fall off, and here we can input a field. So let's just drag and drop the vertex map, which is also weight, into the field list, and bam, now the whole thing is restricted to the area of the growth here. And this is also working, of course, while it's animating. So this is pretty cool. And let me also jump into the vertex map here. So select it, and we will enable the remapping because we want to expand it as much as possible. So it already starts when there is a weight of 1% or so. So let's enable the remapping, and let's just bring up the inner offset to like 99%. Okay, that's looking quite good. Now let's add another plane effector, and maybe let's rename this to be plane vis for visibility. And the next one is going to scale up the clothes. So let's create another plane effector. Again, let's get rid of position, but this time we want to affect scale. Let's check uniform scale, and let's set it up to be -1 because this will make the clones disappear here in relative mode. And yeah, now we have to restrict the effect of this plane effector as well, because the plane effector usually works for all clones. Now we have to restrict it. We are also, or again, going to use the vertex map here. And now you see that we have got, or that crystals appear only in the edge area. So that means that it's reversed. The effect is inverted, and it's also logical because we're having crystals that are the right size, and by using the effector, we scale them down. And this is what happens here. So actually, they would be visible all over the place, but not here. So we need to invert this here somehow. And in here, in the modifier layers, there's one modifier layer that is called invert, and we can use that to invert the vertex map here. So now you can see that they are growing a little bit slower, which is cool. Okay, the last thing I want to add is a little bit of randomness. So let me select the cloner again, and let me create a random effector. And in the parameters, I will uncheck position, check rotation, and just make it 20 by 20 by 20. And maybe let's also set the color mode to effector color, because this way you can randomize the color as well. And this is what we have now. So this is already quite cool. Maybe let me add another set of clones here. Oh, maybe let's also adjust the size using the random effector, also with uniform scale. Let's type in 0.3. So we've got a little bit of variation in scale. And then let's just double this or duplicate this. Let's call this big. And we will create less clones here. But these clones are going to be a little bit bigger, and I will do that by using the scale tool. So some of them will stand out, and this is also something that is quite typical for crystals, and it also looks better. So here we go. That's the growth effect. If we want to render this with the color, including the color in a shader, then we have to create a material, assign it, in this case to both cloners. But once we did that, we see that the random color is not applied anymore. So now we just double click the material, go to color, and in here we go to MoGraph color shader. And that's actually everything that you need to do. If you want to recolorize this, just again use the colorizer. And this way we could randomize or map the color from, let's say, blue to pink or something. And maybe let's also bring this way to the left. And here we go. We've got random colors. If you want to render this now, here's another tip. I would always use straight alpha to render. If you don't know what straight alpha is, first of all, you can find rendering alpha here. Here's the straight alpha. And let's render one time, and you will see that it does something really strange, because it creates an outline here. And this looks really, well, crazy and confusing, but it is actually the right thing because it also renders an alpha, and the alpha is smaller than that. So it will cut off everything that is beyond this, and this way you can get rid of a darker outline. Let me show this in the help, because there's actually a really good example for that. Show help. And this is such a straight alpha example. So this is the RGB output of this smoke here. And as you can see, it looks completely weird. It's just blue, and then there's a little bit of turquoise in here. But once you mask that using this alpha, this is what comes out. So the color is correct. If I scroll up here, this is without straight alpha. So the RGB looks correct, but there's already some dark spots in there. And if you apply this alpha to this, you will get that. And here you can see that, in the 50% or in the translucent parts here, or in the transparent parts, you will have a gray tint, which is actually not what you want. That's why you should always render straight alpha. Okay, 10 minutes left. So let's jump into After Effects. And let me show you how I created this scene. Basically, I initially just wanted to replace the background here. So, or are there any questions until now? This might be a good time to ask questions.
We did have a question about system specs for doing this sort of work. And Darren's referred people towards the system minimum requirements. And we just wanted to comment, wondered if you would comment on it. Young has got a machine which has got 64 gigs of memory in it. And also Logan was wondering about what type of machine, Glenn was wondering about what type of machine you're using and how you find the performance when you're doing these things.
I'm on a MacBook Pro here. I've got a PC workstation in the office, but right now I'm in home office, so I unfortunately don't have the good machine or the fast machine. With the MacBook Pro, I've got 16 gigabytes of RAM, and well, it's not like these settings here are set in stone. So if you have got a project where you just need more memory for the motion tracker, just up the memory for the motion tracker, and then later bring it down again, or just take it away from here, or take it away from the picture viewer and put it into the motion tracker. So you can adjust. Well, it's not like you type them in once and then you can never change them. Of course you can change them. And if you have a big sculpting project inside of Cinema 4D, you might also want to up the sculpting memory. So that's dynamic, and you should adjust this whenever possible. But it's of course good to have as much RAM as possible. Of course, you all know that with RAM previews and with preview renderings and stuff, you can easily fill up like 128 gigabytes of RAM. That's absolutely no problem. And yeah, so more is better. If you don't have as much, like I do currently, then just shift around the values and so that they match for the workflow you're currently having. Usually, you just need the picture viewer to be very high on memory.
Even so, you're demonstrating these things live, and they're working pretty well for you. So it's quite interesting. Yeah. We had another question from Marcus about Mac or PC, and I think you've answered most of those questions in terms of the systems that you've got. Even an average system will tend to perform pretty well.
Yeah, definitely.
Okay, did you see me sidestep that Mac or PC question? I think it's a classic one, isn't it? It depends on many more functions than the one scene for reconstructing, and is often down to personal preference and the other workflows that you've got. Yeah. I think the general takeaway is that because of the nature of switching in between CPU and GPU, then you can manage this even on modest systems. I think in general. So.
Yeah.
Again, another non-answer, but
it's again a it depends answer.
Yeah, absolutely.
Okay, so let me just break down a little bit of After Effects, and 7 minutes left. And actually, I promised not to overrun, So I will keep that promise, and that's why I'm going to hurry up here. So what you've seen is that we've got the wall in the original shot, and I replaced it by using this forest here, and then I just used magic bullet looks for the color correction here. One thing I want to show you here is how I did the rotor work, because motion tracking helps you with rotor work. So this is the rotor shot, and you can see it's, well, I'm just scrubbing through, but it's very stable. And if we have a look at the mat, you can see that there's a ton of 3D solids that I placed in 3D space just to create masks. And let me show that workflow to you, because I think it is quite important. Let me select the tree, and initially I tried to use primate keyer here, but there are too many warm tones, so it wasn't possible to key this out here. It actually would have to be blue or green or something. That was just an initial try that I had, an initial attempt. In the end, I used the 3D camera tracker inside of After Effects, and then I created a ground plane here, of course. Just right click, set ground plane and origin, create solid and camera, and then I've got the solid in here. And well, then I created another solid. Actually, this would be the time when I would also normalize the scene using this very neat normalized track script here that is for free. And then I would create another solid, and I hold down Shift while I select these markers, or that was too early. So I select one, then I hold down Shift, and I create another solid by right-clicking. And then I would just select it and align it properly, like so, and like so. And then I would just scale it up so that it's huge and big enough to cover all of the left side here, like so. And then I would just bring the opacity down to 50% and start creating a mask. So starting from here, I will just do that very roughly, really roughly, and just continue here. And the good thing about this workflow, you can already see it, is that this is a 3D layer. So it already has, or it already is correct in terms of relation to the camera. So instead of moving multiple points at every frame, you have a really good initial shape and just need to correct it at some frames. So this is a very good rotor workflow. And then let me also go to another project, which is this one here, where the whole setup is finished. And let me see what's important. 3 minutes left. I promised not to overrun. So let's go to the crystals, the crystal comp, and you see, if I just double click this footage and zoom in, you can again see the straight alpha here. And here you see in the alpha itself, it is not, or it's not happening. So if I go to this comp, or let me jump out here. Somehow it's not reacting anymore. Do you still hear me?
Yep.
Yeah.
Loud and clear. Still working.
Ah, okay. Now I got the machine back. So here you can see that it all works perfectly. So this is a really good solution for alpha. Okay. Yeah, that's basically everything I wanted to show. Actually, I wanted to show one more thing, but it's just how I created the lens dirt here. Yeah, it was just by using fractal noises and a lens blur. So that's a very easy thing. And yeah, as I told you, I promised not to overrun this session. So I will jump back into the keynote and directly jump here and say thank you very much for attending the series of webinars. I hope you learned a lot, and I can't wait to see what you're coming up with in regards of motion tracking and also other stuff. So thank you very much, and I will hand back to Simon. Or are there any questions that I should still answer here now?
We've been doing a good job of kind of running them along as we've been doing it. And the thing I would say is that one comment we had over the number of weeks that we've done these webinars is that an hour isn't enough time to do the whole gamut of everything in terms of various topics, which is why we've broken this one up into 3 sessions, and which is why we encourage everyone to just share what would you like to see more of. And we recognize it's a balance between enough time to be able to cover it and also the other things that everyone has to do. And so we're going to be running many more of these sessions and perhaps delving in more into how you used on this one, Super Comp, and how you managed to get the trees in the background. That's another whole session or series of sessions in its own right, which is fascinating. But really, that's the thing. We wanted to just encourage you to stay in contact and to keep communicating with us and let us know what you'd like to see, because there's loads more we can share.
Yeah,
I say we, I mean you, Jonas. There's loads more.
Not just me, also Darren, also Matt and Ellie, and we are a whole team.
Yes, this is true. This is true. We are a whole team, and we are distributed across Europe and United States as well. So we can run these. We have been running these in a variety of time zones as well. But please let us know, training@maxon.net. And also those, are we still on your screen? We are. Would you mind bringing up that slide again, please, Jonas?
Which one?
The one that gives the thank you one, yes. Because that's a great 2 Twitter handles to monitor, the Maxon and the Red Giant one, where we share information about new sessions that are coming up. And we often send them out by email if you're a registered customer with us, but those 2 handles are a great place to find out about other sessions that we're running. And I also earlier on today shared the information about the download link for the footage that Jonas used today. So thank you for sharing that with us and allowing us to download that. That's brilliant.
Yeah, you're welcome.
Fantastic. So, and also, one other technical question. Yes, the link to all these sessions that we've been talking about, the registration link is the link to the recording. And it's a peculiarity of GoToWebinar that it requires you to, it looks like you're registering again if you go to look at the recording, but actually it's just how the software works. So we are working to make this more seamless and make it much easier to watch the repeats of these. So bear with us whilst we figure that out. But for now, if you click on any of the links that we send you to register, if they have already happened, it won't be to register, it will be to watch the recording. But yes, we'll figure that one out and make it easier. But thanks for being patient with us.
Yeah. Shall I hand over back to you, Simon?
No, wait, this is good. This is a good page to finish on, actually, because of those 2 handles. That's great. And once again, I'm echoing some things that lots of people are saying. Valentina, Marcus, Logan, Mauricio, Lester and Trish, thank you so much for this week. We really appreciate it. It's wonderful to have like a snapshot or a small little dive into your creative brain and see how you then not only take these things and create them, but also the small little tricks that you're showing us about how to fix problems. Those are invaluable as well. So thank you, Jonas.
Well, thank you for the good feedback. I really appreciate it, and I'm
Excellent.
always happy to share stuff. So
brilliant.
Cool.
Thank you. Thanks also to Darren for all your help this week running the questions. It's a team, as you said, Jonas. It's a team of us doing it.
Exactly.
Great.
Thanks, Darren. Also from my side.
So thanks, everyone. If you want to watch this again in a couple of hours' time, then Jonas is going to be repeating it. But stay tuned for more sessions and feel free to join us on Monday. Join me, Ellie and Matt on the Demystified webinars where we'll be having a final look at workflows in cinema and also how to take Cineware files into After Effects. You'll get the link to that in the email, but essentially it's on the Red Giant blog. I think we shared this many times before, but we'll do that. Great. All right. Thank you, and we'll see you soon. Take care.
Okay, bye.